Ouch. Alright guys, this is a car, this is a tractor, okay? And what we're going to do is we're going to UVAS the situation, okay? This is the stuff I got you to go over recently, wasn't it? There was a lot of this stuff. The canoe question was somewhat similar. So that will do the trick, I'd say. Now, okay, so what you have is you have your car here, very poorly drawn car, and then you have your tractor here, which will obviously need a bigger wheel. Very poorly drawn tractor, and the tractor stays at 6 at all times. It's not speeding up or it's not slowing down either. Great. So 6, an A value of 0. Okay. And oh, he hesitates. I forgot about the hesitation. The driver of the car hesitates for t seconds before applying the brakes. The maximum deceleration of the car is 5 meters per second. Find the maximum value for t which would avoid the collision between the car and the tractor. All right. So what's this car start off at? And okay, so I think what I'm going to do is, would you all agree they have to avoid collision? So to avoid collision, the distance covered by the car is the distance covered by the tractor plus 91.6. Agreed? 91.2 even? Thank you. We all happy with that setup? Okay. Now, the deal is that lead gets eaten into a little bit. Because what's happening every second he travels at 26 seconds, 26 meters per second. Every second he's covering 26 meters, while the tractor's only covering
6.
For argument's sake, if they both travelled for 5 seconds at both these speeds, the car will travel 130, while the tractor would only cover 30, and it would make up 100 meters of that distance. Agreed? Would you agree with that? Now, what we're going to do is we're going to generalize this approach with a distance, with a time frame t. So I'm not going to use t equals 5. I'm just going to use t equals t. So would you all agree that the car covers 26t? Sorry, something's going on here. Would you all agree it covers 26t? And how much would the tractor cover in that time? 6t. And when you take them away from each other? So would you all agree, because it delays t seconds, you were 91.2 meters in the lead, but because of that delay, 20t has entered the chat. Agreed? Okay. So you've lost a distance of 20t. Now, what I'm very interested in knowing is how fast can I get down to, not 0, how fast can I match the car in front of me? And what distance would it cover if I did that? What did it say? Maximum deceleration of? And I'm either after the T or the S. I'll probably go straight after the S. Is that okay? So what about phi squared equals u squared plus 2as? Just going to leave that there for a minute because I am too sure about that just yet. Hey, come here, you. Okay. I think I did it different in my solutions, but we'll give it a go. Okay. So what I think I'm doing here is the following. Phi squared equals u squared plus 2as. What's phi squared, guys? U squared. And then 2as. Minus 10s, yeah? And then, would somebody do 6 squared, take away 26 squared?
6 squared. Yes, we just say negative.
Anybody?
Negative.
So minus 6 for you, thank you. And then divide by minus 10. And you get 64 meters, yeah? So, in a way, if I almost come back to this one, it can be done, it can sort of be done in it. So, would you all agree we know it takes 64 meters to slow down to the proper speed? So, do you remember what we said earlier? The distance covered by the car is 64 meters. It also traveled 26t, didn't it? It traveled 26t. The tractor covered 6t, but it also covered more than that because during we need the time frame it took for that to slow down. By the way, so I do actually need the t value as well. So I'm going to use v equals u plus at. I'm going to do a v value of 6, a u value of 26, and at is minus 5t. And I think I'm going to get 5t equals 20 and a t value of. So it took 4 seconds to slow down, right? And in that time frame, the tractor would have travelled another 4 by 6. It would have travelled another 24 meters. Okay. So, this is not done yet, by the way. It's not done at all. So, would you all agree? While the car was still moving, do you remember that delay in time? It was traveling 26 meters per second for t seconds. The tractor was traveling 6 at that point. The car took 64 meters to decelerate before it reached the speeds, and in that time frame, the tractor traveled 24. And then we have to add on the extra 91.2. Let's bring the t's to one side, and I'm going to get 20t equals 91.2 plus 24 minus 64. 20t equals what, guys? Can anybody do that for me? Huh? 51.2? Divide that by 20. 2 points. Did anybody get this right? Let me see.